Hello and welcome to Practicalli. My name is John Stevenson. Thank you very much for joining me. And today, to kick off a brand new year, welcome to 2020. I'm sure it'll be a year full of interesting things. And so to kick it off, we're going to start with something fairly gentle, although with a few interesting twists. We're going to have a look at Codewars, which is an online website which has challenges, has these Kata style challenges which you can go and solve in lots of different ways. They also provide tests as well, so you can do a little bit of test-driven development around that as well. And yeah, it's good fun, and you can also do it in a competitive way as well if you wanted to. So it's a nice way to, it gives you a slightly different environment than for Clojure, but yeah, the idea is generally the same. So before we get started, just a reminder that all the videos are on YouTube. You can get them via the Practicalli website, and I'm also working on some books as well, so you can get those. They're all work in progress. I think any book is always work in progress. I'm adding some videos to Spacemacs just recently as well. That's my editor I use for all these broadcasts. And if you want to reach out to me on the Practicalli channel, I'm also on quite a few of the other channels in the Clojure and Slack community as well, and there's a link there to get a free account for that. And you can sponsor me in lots of different ways. Oh, I still haven't taken that charity write-off. That's done and dusted. Thank you very much for your support for that. And thank you for everybody who's subscribed to my videos, subscribed to my channel, and everybody. We even got somebody sponsoring me via GitHub as well. So thank you very much for all the support. It keeps me going. So let's have a look at Codewars. So this is me logged in. Can I sign out? Will it? Yeah, there we go. So go in, and if you can go in and sign up and create an account there, and go and select your language that you want. This can be any language. You don't have to stick to that language when you want to. And then it asks you a couple of questions just to figure that out. So this code does not execute properly. Try to figure out why. Oh yes, so let's zoom that in a little bit. There we go. So this would work in some languages, but not in Clojure. And so can we, oh, there we go. Yes, we can, oops. We can change the function to be a prefix function, prefix notation, and submit. Woohoo! There we go, and then you can just link your GitHub account, username and password. So I think I just use my GitHub account to log in, which I think if I go back here, so let's go back to the main page. Then I'll just, when I log in, log in. There we go. I think I just do my GitHub login because it's easier to remember, and then I'm in. Whee! And this gives me a list of it keeps track of all the things I've been doing, all the challenges I've solved, and it gives me, I've selected my language as Clojure. You can also add other languages in there, and you can go in and select different languages and edit the languages you prefer. So you could always add like Haskell in there as well, or Rust, or other wonderful things. There's quite a few different languages. Not all challenges are available in all languages, but then there's enough there for pretty much all the languages there to at least get some benefit out of that. And okay, yeah, and then there's the dashboard. Oh, there we go. Where are we? Oop. Where's my Kata's gone? It has been a while since I've used this. Where are we? I've lost now. There we go. Kata. Is it Kata? Oh, there we go. There's lots of katas you can go and select, and it gives you the languages that they're available in. And where is my... Oh, yeah. And so if you go to your, I think it's go to your profile, you can then go. That's the one I was looking for. Then you can go and see the progress you're making as well. It's got these rankings. You might be able to see that I'm an 8KYU. I'm sure that's pronounced somehow, but I'm not sure how. So it starts off the highest number, and then you work your way up. So like 8 is relatively new beginner. So I've only done 11 kata. And then you, once you've done so many, you go to 7, and then 6, and then 5, as you get more experience as you solve more challenges. And I think you can also add your own challenges as well, your own katas. So that I think that would also help boost your rank. And so one thing I haven't quite worked is it says I've completed 5 katas here, but then it says, oh, this is an honor breakdown, so I'm not quite sure why it says 10 there and 5 there and then 11 there. I'm not quite sure on this numbering system. I'm sure there is a method to it, but I'm not sure what it is. And then if I click on kata, I can see the ones I've completed. Oh, and then we've got the one I'm going to work on to start with today. So we're going to look at this rock, paper, scissors. And so this is just, it's rock, paper, scissors, kata. Let's copy that. I'll paste that into the chat window as well. Hopefully that one works for everybody. And so this is doing the rock, paper, scissors game, which I think is fairly universal, although it's called different things in different languages. Yeah, so it's a fairly simple game. People use this game to help decide on things. So rather than flipping a coin, you can do rock, paper, scissors to help that. And it's fairly simple rule. So if we look at the example, so you have a return which player won, and if there's a draw, you return draw. So these are the outputs that we want. So this is what we want our function to return, and this is the kind of the function signature, more or less, except we just put RPS inside the bracket because it's Clojure. And keep it all nice and tidy inside our parens. And so it even gives you a nice visualization of how things work. So scissors beats paper, paper beats rock, and rock beats scissors. And so this is quite it's quite a deterministic set. It's a very, I think this is called like a zero-sum game. So if there's not a draw, then somebody has to win for somebody else to lose. So for somebody to win, somebody has to lose. Okay. Hopefully that's fairly easy. So, and then I've already done this, but I can go back and train again, and I can. It's trying to beat my best time to solve it. Oh, interesting. I could quite easily do that. You just copy paste the solution I've done before, but the main benefit of training again is to go and solve it in a different way than you did previously, and so it's a good way to practice over and over again solving the same kind of challenge but in different ways to explore the language that you're working with as much as anything, as much as the problem space. Okay, so let's train again. And so we've got our instructions here, which are fairly simple, and we've got our output, which is results. Oh, and we've got past solutions there as well. So there's like solutions. Oh, my solution I did last time as well. Cool. And so we're starting with, can we? Oh yeah, we can make this bigger. So we've got in the in the in the right hand side of the website, then this is where the code is. So you've got a code editor here. I think I've put it into Vim mode. But you don't have to. If you're not using Vim mode, then just select Emacs instead. It'll be what you're familiar with. But it's got a fairly nice little Vim mode, and because I'm learned Vim, I'm going to use that now. And if you want some more space, then you can just maximize the editor, so you've got plenty of space. I'm going to do this. And then we've got code as well. I think that's underneath. Let's just hide me for a second. Oh, there we go. And then so you've got the you can also maximize the tests as well. So this is a test that's been provided, and we've got a def test. So it's just a normal clojure.test, and so we're defining a test. The test is made up of like several sections, which we define with this testing function. It's just mainly to add documentation to the results. So when we have these assertions here, we know that they're in the context of player 1 should be winning. And so it gives us some context about what the tests are trying to achieve, or trying to the result they're trying to give. And because we're doing multiple assertions that are basically calling the same function, so we're calling the same function, we're trying to see whether the result of calling RPS with player 1 and player 2, is that going to be player 1 won? And so rather than doing several is statements, we're actually doing an R statement, and it's going to run over these there as well. I'll show you that example in the code I'm going to do there as well. So you can either write these, you can either write the solution in this editor, or you can drop down to your own editor as well. So I think I did this one in Codewars itself, but what I've done is also put it into Emacs, and I've also described kind of like my thought process and analysis I went through as I solved this. And this code is available online. I've put this into the Practicalli organization on GitHub in these Codewars guides, and some instructions about how to actually use these guides as well. So if you go to Codewars guides, it tells you how to use the repository and how to work with a project. So essentially what I've done is create this repository, and each of the directories in the top level are Clojure projects. These are Clojure projects that I've created with deps.edn. So just using, I should update the README for that. So just using Clojure command line tools and CLJ new, so things that we've shown before. But I'll update the docs so you can know exactly how to do that in here as well. But the details are all in the kind of main README for this as well. So it shows you how to start a REPL on the command line, and how to do run the tests as well. So I'm going to put in a few different test runners in each of these as well, so you can choose which test runner you actually want. I quite like EF test. Seems to be pretty, gives a nice output. And Codewars is very good, but it's quite there's quite a lot of things you can do, so it might be a bit overkill for these things, but it's one way to actually go and learn how to use some of these test runners. Okay, let's get back to the solution of that. Any questions so far? No questions from the audience. Where's my mouse gone? There we go. So let's go to Emacs. Woohoo! We've got this rock, paper, scissors game. I put a link into rock, paper, scissors on Wikipedia as well, because it explains some of the history of that as well. It's quite interesting. And again, it's a simultaneous game, so you're basically choosing your option from rock, paper, scissors simultaneously, and then you're showing it, and there's only 2 possible outcomes. So it's a relatively easy game to model. So you can either have a draw, or one player is going to win and the other one loses. So it's fairly straightforward. So each player chooses a shape, and then the shapes are compared against the game rules, and then the results returned. So the only really complex thing is kind of like figuring out the game rules. And that's fairly straightforward. You could do it in a procedural way, but the tendency would be to have like multiple nested ifs. So if this condition, else, then if, else, then if, else, then if, and else, then. A really horrible, nasty thing. You could have a condition which would kind of help manage some of the nesting there as well. But you're still going to have a lot of repetitive code here. So here we've got function, it takes 2 arguments, and then we have a condition. So if the draw kind of condition is really easy, so just comparing if the player 1 and player 2 are the same, then you just return a draw. Then it's the working out who's won one. You could just put every single combination in there. And there's not a huge amount, so you're going to do 2 for rock, 2 for scissors, and 2 for paper, because you've already got. You don't need to compare like rock for rock, because you've got that in the first condition of draw. So if we get past this first condition, then it means that those 2 things are different, which means if player 1's got a rock, he's either got the player 2 must have either scissors or paper. But they still can be quite verbose, because we've got to put every combination in there. So the approach I took really was to use a map. And in the past we've used a hash map as a dictionary lookup. And in some languages, like Python and so on, then people refer to a hash map as a dictionary as well. So it's quite a well-known concept to use this map as a way to look at things. And in the Clax alphabets that we did a while ago, then I think I did that on here. I'll have to check actually. Then we basically had an alphabet of A to Z, and for each letter of the alphabet we had a code. So we could basically create a very simple encoder decoder for our application. So we had we just did a def alphabet. Boom, boom. And then we did A, and then we gave it things like that. And so we did that for each letter of the alphabet. And then we could look up, we could take a word and look up each character of the word and create an encoding for that word in a different language. So it translates from one state, being English language, to being more of like a binary state. So it's a nice, in a way, it's a very extremely simple state transition model. So you're going from one state that is English language to another state which is the encoded binary. And so we can use a hash map to define the winning choices. So what are the win conditions for a player? And if we know, because we know that if one player wins, then the other must lose. And we know if no player is winning, then we know it's a draw. So we don't have to do every single combination. We only have to do the winning combinations. So what we've got here is, with the key, we've got the choice of a player, and the value it points to is really the the value that that first choice will beat. So rock will beat scissors, scissors will beat paper, and paper will beat rock. So it's very easy to define the whole game just as a map, as a state transition, as it were, and then we can just run our conned condition over the top of that. Okay, so what does that look like? So we're defining this winner states name, which just is a way to refer to our rules map. And so that's just exactly the same. And then we just define a function that is essentially just a conned condition. So we're taking in player 1, player 2, and they're just strings, and then we compare to see if they're the same. So that's what hasn't changed. But then we can just basically do the calculation of whether something's won just by a single one-liner. So we get from the winning states the player 1. I mean, we could actually just do winning states player 1 as well. We could use the map as a function if we wanted to, but just to make it absolutely explicitly clear what we're doing, so we can do get from winning states from the map player 1. So if player 1 was rock, then this would return scissors, and then we can see whether scissors is equal to player 2. So if player 2 chose scissors and player 1 chose rock, then player 1 wins. And if that's not the case, then, well, we've checked to see if there's a draw, and it's not a draw. We've checked to see if player 1's won, and player 1 hasn't won. So by default, player 2 must have won. So we can just put an else condition at the end there, and then say player 2's won. So if we do rock, paper, scissors here, did I evaluate this? Oh yes, I've updated my markers so I can see what I'm doing now. There we go. So if I evaluate this, player 1's won, rock, paper, scissors. But if we change this to paper, then player 2's won. Ta-da! So that's really simple, kind of in terms of code. It's quite a simple solution to that. I quite like that. And so you can do some quite nice, even quite convoluted kind of state transition using a map, and it makes it just very easy for somebody to come along and look at this map and understand the rules of these of the game, or the rules that are inside the state transition system that you have. Any questions? No questions. Boom, 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 boom. Okay, so that's that. We could. I did tweak this a little bit to add an explicit check for player 2 as well. Just because we don't really have any. If somebody did lizard here. There we go. Then player 2 wins. So if somebody makes an illegal choice for the rock paper scissors game, then player 2 is going to win. I guess that makes sense. What happens if we do the other way around? Oh, so player 2 wins. So if player 2 makes something up, then they're going to win anyway. So there's a bit of a flaw there in the game. Whereas if we do this version, and I've added the extra condition here, then if somebody has something else, then it gives a kind of like an error message. If we evaluate this, and then we do this. So now rather than player 2 winning, is checking to see whether are we playing rock paper scissors lizard Spock, which is in fact an alternative version of rock paper scissors, which I think some people might know from The Big Bang Theory. And in fact, you can find that out on rock paper scissors, because I think it was The Big Bang Theory got it from somewhere else. So there's quite a description of rock paper scissors lizard Spock on Wikipedia, and it's kind of a similar game, but it's you've got a few more options to choose from. So, but the idea is the same. It's still a 2-player game. You're still having people making a choice, and they've still got rules to do it. But in this case, then you can see that lizard will poison Spock, and lizard will eat paper, and then rock crushes lizard, and rock crushes scissors. So because there's more options to choose from, then there's more conditions in the state that you want to check. There's more conditions in the rules of the game. But that's not too much of a problem. So if we go back to here. So if we want to add more objects to that, one of the simplest ways I thought of doing that was to just add a as the value, rather than just having a single string. You can have here we've got a vector, a collection of the possible things that rock will beat. So rock will beat either lizard or scissors, and Spock will beat scissors and rock. And so this pretty much is the same, except you just need to check whether the second player has one of these, rather than just comparing it for a single string. So we extended this, and all we did was it's pretty much the same actually. Still taking 2 players, cons, still doing a draw, but then for the check, we've actually got we're using sum to find the whether player 2 is within inside the vector we return. So this will return a vector, and so let's show you this in action. So if I evaluate this, put this in debug mode, and then we can call this. Oh, I've changed those names. Whoops. Bit of hacking. Rock paper scissors lizard Spock game. There we go. So if I evaluate this, and then we can walk through just by pressing N. So we've got this debug on. So we've got this debug menu. We can just step through the lines of code. So player 1 has chosen rock, and player 2 has chosen lizard. They're not the same, so draw is not going to be, so that's going to be false, so it's not draw. And then winning state, so we've got this map that we're going to get from. We're going to get rock from that. So this is going to return a vector of 2 strings, lizard and scissors. And we are going to compare that to lizard. And so it's checking to see player 2's in there. And so because player 2 is in that vector that's returned, then player 1 has beaten them. And so some is quite useful. So there's a quirk in I guess the quirk in the language that trips people up sometimes. There's a function called contains, which doesn't always kind of work as you would like it to do. So it's based on the structure of the type of the collection that you're working with. So if you do contains on a vector, it's going to look up to see whether let's do contains. Let's show you this in code. Do contains on then we do a collection 1, 2, 3, 4, and then does this contain 4? What do you think it would? Because the 4 number is there, but actually if we evaluate this, it's false. What's going on? Oh, that's crazy. So what it's actually doing is using because this is a vector, it's using the index. So this index is 0, and this is 1, and this is 2, and this is 3. So there isn't actually an index 4. So there's no value here. If we put 5 in there, and this is going to be true now. Woohoo! Spooky. So it's very easy to get caught out with that one. But with some, then this allows us to check to see whether we've got a string inside a collection. Some requires a function to work. So what I've done is just put in the player2. So just put player2 into a set. So we can then use a set as a function. You could write a little anonymous function to do this. So we could do, rather than that, we could do an anonymous function. Okay. Oops, what did I do? I broke it. Boom, 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 boom. And then round brackets, yes. Boop. Yeah, so we could do an anonymous function and just compare that with the value that we get from the collection as well. I quite like the set. It's quite nice because you could then also have multiple things in the set and compare them to see if we were dealing with much more complex rules, you could kind of still keep it fairly simple by having multiple things that we're checking for player 1 against multiple things we're playing for player 2, and if any of them matched, then we'd get a positive result. So if it's in there, it's going to return the value, and that is considered as like a true result. So then we'll actually just return player 1, and we could do something simple for player 2 as well if we wanted to have a bit more defensive programming in there as well. And but yeah, it's essentially allowing us to extend the game quite easily, and we get the right results that we actually want. Let me just get rid of that. Boop. The spot game. There we go. Any questions on some? Nope. There was a few alternative solutions in here. This one was quite interesting because what they did was put in also the results into the map as well. So if player 1 chooses scissors and player 2 chooses paper, then player 1 has won. And in here, if the player 2 had chosen rock when player 1 had chosen scissors, then player 2 is winning as well. So this is more self-contained map. It's got everything in there you need, and what it's doing is just calling the game map to get player 1. So this would return the map. So this would return one of these maps here. Yeah. and then we're using that map as a function with the arguments, so with the player2 argument, and if that doesn't return a result, then we're going to return draw instead. But if player 2 does return a result, so if we get player 2, so say if we've got player 1 as chosen scissors, so RPS game scissors, then what it does is return this map. So this map goes into into this place. It replaces this, and so then we use that map as a function to look up the value that player 2 is, and if player 2 is paper or rock, then it's going to return one of these values. It's going to return the my mouse has gone to sleep. It's going to return either player 1 if it's paper, or player 2 if it's rock. But if player 2 also has scissors, then there's nothing in this map for player 2 value here to pull out. So there's no key in this map that matches. So this draw is like a default value that it's going to return because it didn't find anything in the map. So that's quite the succinct thing. So everything is kind of pretty much self-contained in one map, and you've just got a simple kind of two lookups on a map on different levels of nesting of a map. And if you don't find a result, then you just return a draw. I think this is just using a set. Oh yeah, so this is like an expanded version of my my set version here. So when we introduce this sum, so rather than using sum, this is just explicitly putting these things here. So if these things are here and from player 1, player 2, then player 1's 1, otherwise player 2's 1. Cool. Just some other things about the, so we've got that, so we can put the answers into Codewars and see if it actually works. So we can actually just copy and paste these. Although you have to be careful with the naming of them. Where is it? Where is it? Oh, I've lost my mouse. Let's use the keyboard instead. There we go. Boom. So you'll need to keep the names of these functions the same, I think, because it's tied up with all the tests. And I think because it runs as sample tests, so let's grab the code. Where are we? There we go. So let's grab this first. So this is our map, so we can call that whatever we want to, because we're calling that from the oops. What did I do? There we go. Paste that in. Come on, paste. Why? Why is it not working? Oh, no. Yeah, I can't get to paste now. Oh, there we go. Finally. So let's paste it in there, and then we want to have the algorithm that uses that as well. I should just make this bigger. There we go. Boom. And so we just want the cons statement. And then copy that back to 1. do we do this? There we go. Yeah. Just pasting with the middle mouse key seems to work the best. So, oh no, it didn't. Oh. Let's paste it the same thing. That's not good. I think this is only the only downside of doing this is I wasn't quite getting the copy paste working properly. Let's see. Why? Boom. No, didn't want to do that. Oh, there we go. So do insert and then Control V to paste it in. That seems to work. So we've got the code in, and then you've got sample tests to run. So we can run that. So we're calling RPS tests, and it's going to call RPS. Let me show these tests a little bit easier. Form. So we got, so this is just a copy of the rock, paper, scissors test namespace into Emacs. And so that it's using the R function rather than is. It just means that for everything after that expression, it's going to put them into the above calculation and work them out. Oops. So R is the same as doing is to equal to 1 plus 1. So this is the value we're wanting. This is the value of x, and this is the value of y that we're putting into the above statement. So this is kind of like the structure of the function we want to call, and this is the actual data that we want to actually call to replace x and y each time. So this is going to call x and y, or equals xy each time, but with each of these values. So each of these are effectively is assertions, like we've got here. So it just saves a little bit of code, a little bit of typing there, and a nice way to, but effectively it's running the same thing. So we've got player 1 winning. It's just calling the rock, paper, scissors game with 2 arguments, and then seeing what for each of these. So player 1 should be winning on each of these, and then player 2 for this one, and then draw for this one as well. So let's switch back to Codewars. And we can run our sample tests here, and it will give us some output and tell us whether we've, ooh, what have I done? I've broken something. That was working before. Oops. What have I done? Oh, player 1. Why? Oh, what? Yes. Oh, yes, of course. I put out the longer names in here. There we go. So P2. There we go. P2. There we go. Oh, I suppose I could have changed it there. That would have made more sense, but never mind. So we can change the names of the arguments. That wouldn't have affected the tests at all. So I think that should run. So it's useful to have these sample tests before submitting, and then you know that your code works, or at least works with the tests. So we've run 9 assertions there. So each of these tests has 3 assertions. So each of the R statements has 3 sets of data with it. And then when we're happy with our code, because we can go around and refactor it. We don't pass all the tests. We can go in and refactor our code and go around and around. So this is like the test-driven approach. And so if you are using, if you are editing the code directly in Codewars, then you can basically just do. You've got your test already. Now you just need to make the test pass. So you can do like a the simplest possible thing and walk through until you've got a winning solution. And when you're finished, you can then go in and press attempt, and this will run even more tests, I think. Oh, it's passed all the tests. Oh, it's running all the same amount of tests. And that's submitted, then I can submit that final to that. And this is where you then get to see other people's solutions as well. And you can give some feedback on the Kata and things like that. So there's, yeah, you can get to see a list of all the people, everybody else's Katas. And you can also vote on which you think are the kind of the ones with the best practices. So here somebody's done something similar, except they're just using a set instead of a map, and just got pairs of winning combinations. Yeah. So if you've got rock, you're going to win with scissors. If you've got scissors, you're going to win if the other person's got paper, and so on and so on. So you can just see whether P1 and P2 are the same, and if they are, then player 1 wins. And then, as we say, if player 1 doesn't win and it's not a draw, then player 2 must have won. So that's quite a nice approach there as well. Not quite sure what's going on there, if it's just the formatting of that. Looks strange. But anyway, this is when you can go in and have a look and compare your solutions with other people. So you can compare it with your solution as well. I don't actually know what that does. Oh, it just shows you your solution. There we go. There you go. Oh, there's me. There we go. So you can vote for, obviously, mine. All mine are best practices, obviously. I'll leave that for you to decide. Cool. And you can also run the tests, because I've copied the tests over. I can run the tests locally here as well. And in case hopefully I didn't break anything in the run-up to this. So here I'm just running all the tests inside Emacs, and they're all running. So it's run 29 sessions, because I've also got the I've also added rock, paper, scissors test to this as well. So like for rock, paper, scissors, lizard, Spock. And so I've just basically taken the previous test, but I'm just adding lizard and Spock to that. And so you can do the same thing. So you can add like several more combinations to test here. I think 1, 2, 3, 4. Yeah, so I think there should be 5 for each. So I can add a couple extra ones for those. So I'd need to do for draw. Then we'd do lizard, and Spock and Spock. Oops. And just do and I'll add those for player 2 a little bit later on as well. That's it. And then also I'm going to add to the projects, so you can some test runners. So if we have a look at the project file, the deps.edn file, here I've got test runner in here, and so I'm not quite sure how to do this, but I'm going to put a test runner here, but also encourage you to put the test runners in your own clojure/dev.deps.edn file. Let me show you. So if I open the file, so in the root of your home directory, If you're using the Clojure CLI tools, then there's a Clojure folder, and there's a deps.edn file. So I put all my test runners in there. So I've got the alias to create a new project. I've got an alias to run the Rebel readline, and I've got things like adding hot loading dependencies, and then a whole bunch of test runners I'm putting under there as well. I quite like EF test. It's nice and gives nice formatted output. If you really want to go overboard in your testing, if you really want to kind of use lots of different functions, then Clojure is a really nice tool there as well. But it does mean that I can go to my terminal as well, which is in there. And I'm just going to make that bigger. And I can run tests here as well, which I've been doing before. So I'm running, this is the runner that is in the project def. And this is just the Cogdetect runner. This is running and is running 22 sessions. And then there's also EF test, which gives some nice output there as well. Boom. There we go. Especially when you've got more, if you've got errors there as well, EF test is quite nice to kind of format the errors so it's a little bit more readable. Okay, well, I think that's all I've got time for. Yeah, we're coming up to time. So I did have a little go at some of the other ones that are under here. Let's see. So I started going through printer, I think. Cool. Let's see. I don't know if I finished this. Yeah, so printer errors. So I'll do we'll do this at some other time. But basically, you've got control strings, and you've got to only some of the control codes are legitimate. So you've only got like the first half of the alphabet are correct color codes, and the rest of them are errors. So you basically just have to sort out the correct codes from the error codes. So I'll do a video on this one as well in a very near future. Okay. Well, thank you very much for listening, and I'll see you next time. Thank you. Bye-bye.